Okay, so this is the typical graph for what we call our logistic growth model, right? This one typically is for population, right? That as you may notice, a certain initial value of the population, it will consistently or basically exponentially, exponentially increase, and it will reach a certain what we call carrying capacity, right? What we call it's basically a horizontal asymptote in there that it's not gonna go further anymore, right? So even if you do the overpopulation, there's a limiting capacity in there, and that's the only limit that it's gonna reach, right? It's not gonna be increasing forever, right? It might be what? In some cases, it might be, in biology, it might just be the surrounding like medium itself, right? If it's just like a cup or like a dish, then that will be the limiting capacity, right? You are only limited to the entire boundary, right? After that, you cannot grow any further anymore, right? For a lake, just the same, right? Even if you do some overpopulation of say algae in there or fish, well, you are limited by the boundary of the water and also the nutrients on the water as well. So that will, limit the population in there. It will not increase forever. Are we good? Right? So that's basically our logistic growth model, right? And typically this is for population growth, okay? Either of bacteria, fish, any type of species is basically just the same, okay? So with that being said, it's always of that form, C over 1 plus A e to the negative bx power, right? If you remove this, right, that's C over 1 plus A, that's your initial value, okay? Why? Because if it's initial value, your x will be 0, right? And e to the 0 is just equal to 1 anyways, right? Good. So with that being said, with zero property for exponent, that's going to be 1. So that C over 1 plus A is basically your initial population at the start. Okay. Carrying capacity, that C in there is the limit, right? It's not going to go beyond that C. Okay. Next one, the growth rate. That B in there is the rate of growth of the population, right? And you would always see a graph that's similar to this one, where that y-intercept is always the initial population, and that C is always going to be the ceiling value, right? What we call the carrying capacity, definitely in a function that's also called a horizontal asymptote, okay? It's not going to reach that value, okay? Now, let's apply this one to a specific question. Here it is. Let's read this question in here and see how we can work on it, okay? Corey, go ahead. Let's read this question.
For the following exercises, use a graphic calculator in this scenario. The population of a fish farm in T years is followed by the equation PT equals 1,000 divided by 1 plus 9e negative 0.16.
Thank you, right? So later we're gonna graph this function, right? But before we graph that function, let's analyze some other key features of this equation first, right? Let's read number 18, and what are we looking for that, okay? Angelina?
What is the initial population of fish?
All right, so how do we get the initial population in here? Well, as we said a while ago, initial value or initial population is just basically C all over 1 plus A. So with this being said, what is your A equal to? What is your A equal to in here? 9. Very good. So that this 9 is letter A, right? What is your C? Well, B first. What's your B equal to? B. B is the exponent. Okay, so this B in here, yeah, without the negative, right, is the B, 0.6. What is your C in here? 1,000. This one on the numerator is your C, 1,000. Good. Once again, Your A is the multiplier of E. Your B is the exponent. Remove the negative. And your C is the numerator, right? So again, A, B, C. Cool? Right. Well, let's get now the initial population, right? So according to this, the initial population should be equal to what? C over 1 plus A. So that's going to be what? 1,000 all over 1 plus 9. Good? So you have the expression already in there. Okay, so initially, how many fish were there at the start?
100.
1,000? 1,009.
Well, 1,000 over 10, right? 100, there we go, right? 100 fish initially, right? Are we good, guys, with that one? Okay, so at the start, there are 100 fish in there. You good? Okay. Next, let's read number 19, right? Let's read number 19 in here. Hampton, go ahead, please.
Alright, to the nearest tenth, what is the doubling time for the fish population?
Right? Simply said, how long will it take for 100 fish to be how much? What's the double of 100 fish? 200. Very good, right? That's correct, right? In number 19, the question is this, right? How long will it take for 100 to be what? 200 fish. So in short, what's that time? Are we good, guys? So plug it in there. What's your P? What's your population? 200, right? So we're gonna put it in here like such. Hope we choose a different color. So you double 100, 200, okay, is equal to what? 1,000 all over 1 plus 9 E, what's this? Negative 0.6 T. And again, you're solving for the T. Are we good? Right. So in here, we're going to use our exponential equation method a while ago, right? So what's the best thing to do in here? Step 1. Yeah, write it in the form what? What form do you want it to be? A to the B is equal to C, right? So in short, you see this one in here? You want this in here, right? So what do you do first? Well, the first thing to do is to what? You see these two? Flip them together, right? So if you flip them, so this is going to be what? 1 plus 9E negative 0.6 T is equal to what? 1,000 over 200, right? Get it what I did, guys, right? Because you want this form. So you want this to be in here. Well, flip them. We good? Okay. What's 1,000 over 200? 5. Very good. Okay. Again, you just want this. So get rid of those two. What do you do next?
-1, you get
Minus 1, very good, right? So minus 1 here, minus 1 here. Cancel out, hence we got what? 9E negative 0.6 T is equal to what? 4. Get 4? Right. Get it, guys? 8.
So you can swap out the 1 plus 9E
Mhm.
with 200
Yeah.
in this situation simply because we're assuming that they're equal. In any other situation you could.
Yeah, well. We're not assuming they're equal, they're
Yeah.
actually equal, right?
Right, yeah, but you can, okay. Just making sure.
And we're assuming that this is not 0. Well, honestly, this is not 0 actually, right? Get it? Get it, guys? Okay, after that, what do we do then? Divide 9 both sides, very good, right? Again, do not round off, right? So cancel this. E negative 0.6 T is equal to 4/9. Okay, so that's already of the form A to the B equals C. What's next again? What do we do? convert to logarithm, right? Let's convert that one to logarithm, right? Let's step number, what's in here? 2. Convert to log, right? Log convert. So in short, you want it to be the form what? Log base A of C is equal to B. Are we good, guys? Right. So let's plug it in here. Let me just go ahead and erase this one a little bit. Convert this to log. What's that gonna be, guys? Automatic, that's ln, right? Because it's E, right? So ln of what? 4/9, very good, is equal to that one, right? Negative 0.6 t. Good. Well, you just want the t, right? So what do we do next? Solve for t, right? So how do you solve for t? Divide both sides by negative 0.6, right? Very good, right? So divide this by negative 0.6. There we go. And again, do not round off until the final answer, right? So t approximately equal to, right? Oh, what's that gonna be? ln 4/9 divided by negative 0.6. Let's plug it in your calculator. Ready? There we go. ln parenthesis 4/9. There we go. Divide this by negative what? 0.6. Very good, right? Did it say how do you round it off? Nearest what? Tenths, right? So when you say nearest tenths, let me just is that what? 1.3 or 1.4? 1.4. Good. So I'm going to put in here t is equal to 1.4. Did it say years, minutes, hours? Let's go back to the problem. It says, where is it? Years. Okay. So to the nearest 10, that means this is what? No, number 19, right? And again, this is what? This is the doubling time, right? We good? Yeah. It took 1.4 years, right, to double the population of the fish in there. Are we good, guys? Right? Okay, let's do this one. Number 22, right? Number 22. Let's read number 22. What did it say in here?
What is the carrying capacity of the fish population?
Thank you, right? So we got that word. Carrying capacity, right? Okay. Again, what did we say a while ago? To get the carrying capacity, just look at what? C, right? So to get the carrying capacity in here, carrying capacity,
That would be 1,000.
and that's going to be what? 1,000 fish. In short, it will not exceed, right, 1,000 fish. We good, right? That's the limit, right? It can go 999 fish, but it cannot go beyond 1,000 fish, right? That's the carrying capacity. That's the limit. We good, guys, right? What else do we have in here? Oh, okay. One last in here. What do you think is the growth rate? It's not being mentioned, but what do you think is the growth rate for such? 0.6, right? So when you say 0.6, that means that's equal to what? 60% growth rate. Right? So in terms of percentage, that's 60%. But in terms of decimal, basically it's 0.6. Are we good, guys? Any questions regarding that one? Questions? Let us answer in here one last. Let's answer number 20, right? Let's answer number 20 for such. Corey, go ahead, let's read that one.
To the nearest whole number, what will the fish population be after 2 years?
All right, so basically that one, thank you for that. Basically just evaluate the function at t equals 2. Good. So with that number 20, you see this t? Just make it what? 2, right? So you get the population, right? So let's see. P after 2 years is equal to what? 1,000 all over what? 1 plus 9 E exponent negative 0.6 and your T is equal to 2, right? It says whole number, okay? Plug it in your calculator, see what that value is going to be, okay? Guys. So again, number 20 is basically just evaluate the function at T equals 2, okay? Okay, let's put it in here. Calculator work. 1,000 over 1 plus 9 E exponent is shift 6. Get it? Negative 0.6. Multiply that by 2 years. Okay? What did we get? 269 or 270? 269 fish. We good? Get it? Okay. Because after 9 is 4. Right? So,
I was just rounding 4 to 5 off the 8.
no, because the whole number, so you look at the digit on the right of the whole number, right? So, if it's 269, if it's 270, actually it's 269. Are we good? Right? So, in here, you're going to put in there 269. Let's go back in here. 269 fish after 2 years. Good. So basically number 20 is typically no need to solve for anything, just evaluate the entire function at T equals whatever is given in that case. Be careful with rounding off, alright? It says whole number, do it. If it says tenths, then do it like that, right? And also you only round off on the final answer, okay?